Okay, in this video we are working on writing one variable equations with variables on both sides, and we're going to talk about coefficient and constants. Okay, the coefficient is a number that's in front of, like 3 is a coefficient. All right, coefficient in my world is basically you just say a number. Okay, it's a number in front of usually a variable. This is our variable right here. All right, and so my coefficient of x is 3, just to let you know that. All right, so what I do here is we talk about Pemdas, and so think of Pemdas. All right, Pemdas is, please excuse my dear Aunt Sally if you remember this. When we do not have a variable, we go Pemdas direction. However, in algebra, we always have a variable. We go in the opposite direction. So in algebra, eraser's not working. In algebra, we go in the opposite direction and we do the opposite. So we go in the opposite direction and we do the opposite of each one. So, like, I'm looking at my x. I always ask these questions too. What's my variable? My variable is x. What's being done to x? It's being multiplied by 3 and it's being added by 4. Alright, so in algebra, if we go PEMDAS backwards, some of my students call it sad math. If you go backwards, instead of plus 4, we're going to subtract 4 to both sides of the equal sign. Alright, this becomes a zero pair. A zero pair is when a number and its opposite. That means one's a plus, one's a minus. It's the exact same thing, except they're opposite. One's a plus, one's a minus. And their total equals 0. So we call that a zero pair. Now we're going to bring down my 3x. Now this area here, we have to be very careful here. And the area I'm talking about, I usually call this the lookout section. This is the lookout section right here. Because we have to watch our signs. We got a lot going on here. But when the signs are the same, no matter if they're both minus or both plus, we add the numbers and we take that sign. Now, if the signs are different, if one's a plus and one's a minus, we follow the integer rule and we subtract them if they're different. Think about it. The word different means subtract. And so if you subtract them, then you go with the number with the sign with the biggest number on it. Okay? So, but in this case, they're both the same, so we're going to add these two numbers together. Alright, and when we add 11 plus 4, we get 15. Now, it is a negative because I have a negative plus another negative gives me a negative 15. Alright, so we've done that part right there. Now we're going to still keep moving up. And when we move up, we see that we are... next it says multiply by 3. Well, if you look at your x, you ask yourself, what's being done to x? It's being multiplied by 3. So what's the opposite of multiply by 3? You divide both sides by 3. Okay, and so 3 divided by 3 is 1, and 1 times x is x. Now 3 goes into 15 5 times, but you have a negative left over, so it's really a negative 5. Or you could say negative 15 divided by 3 is a negative 5. Okay, so I've decided to go ahead and try to do another problem for you. I wanted to change it up a little bit. This is one that happens all the time, and I want to make sure that we don't mess up on this. Okay, if you kind of notice, I've switched things around. Now, we could switch things around. One thing that I always make sure kids understand is the sign follows the number. So when someone asks you how you are, you say you're 14. All right? We know that you're really positive 14. If we know something is negative, like a 3, we say negative first and then the 3, not 3 negative. All right? And so the sign always follows that number. So in this case, the problem above, if you look, the negative and the 6, that's really a negative 6. Even though it's subtract, it will be a negative. Now, if I take away this 7, I'll give you an example. Doesn't it look like negative 6 now? It's the exact same thing. It's just the way we use them. And how we position them. All right, so right there I have 7 minus 6x equals 12. And so remember what I said, the sign follows the number. And so what we're going to do is, remember I talked about PEMDAS, we're going to think of PEMDAS. Because we have a variable, we're really going backwards. All right, now 7 really has a positive sign on it. It's the sign in front of it, so that's really a positive 7. All right, so the first thing I ask is what's being done to the variable? A lot of kids will say, hey, it's being subtracted by 7. It's not really being subtracted by 7. The negative is with the 6. So it's really being added by 7. So we really say plus 7. And then it's being multiplied by negative 6. All right, this is where people mess up. So this is very important that we go over this. All right, so I'm going backwards. And the first thing I'm going to do is try to get rid of my plus 7. So the opposite of plus 7 is minus 7 to both sides of the equal sign. All right, and when I do this, this becomes that zero pair like we talked about before. All right, we bring down my negative 6x now. See how it became a negative? Now, this we were talking about earlier this is the watch out area, the lookout section. I'm looking at my signs. They're different. They're not the same. They're different. So different means subtract. So 12 minus 7 is 5. It's a positive 5 because the 12 is bigger than 7 and it has a plus on it. Now we're going back, still going up the ladder, or up SAD myth, or Pemdas backwards, and we see we're multiplying by a negative. So look at my variable. X is being multiplied by negative 6. So the opposite of multiplied by negative 6 is going to be divide by negative 6. So I'm going to divide both sides by negative 6. Positive 6, a negative 6 divided by negative 6, that cancels out, or really becomes 1. All right, and 1 times x is going to give you x. So this will be x. Now 5 divided by negative 6, we'll just put the negative in the middle. You can put it at the top. You really don't put it on the bottom in the denominator area. You can put it in the middle, so you can say negative 5, 6. Some people put negative 5 over 6. Both of those are correct. Preferably, we'd like to look at it like this.